Hello everyone. In this lecture I shall discuss the half range sine and cosine expansion. In my previous lectures I have discussed the Fourier series of 2 pi periodic functions and the Fourier series of arbitrary periodic functions. Okay. Here likewise the function f is 12 periodic. Right, L is an arbitrary period. But the function is defined in half of the interval. The interval be 0 to L. Okay, means it is given in half of the interval, not in the whole interval. The whole interval is minus L to L, right? Then it has possible even extension or it has odd extension, right? So let me to tell you one example. You consider one example, fx is equal to x, right? So fx is equal to x. If you think of the graph of the function, the graph of the function is like this, right? The graph of the function is, it is defined in half of the interval. It is my 0 and it is my pi say, and the graph is fx is equal to x, means this is the graph here, fx is equal to x, right? So now this is half of the interval. Now we can extend it. What will happen to its extension? Okay, we can have its possible extension, right? We can have its possible extension. We will extend it. Possible extension. You see, we may extend it in this way. Suppose the original function is my, this is my original function, right? This is my original function. It is from 0 to pi, and we want to extend it. What will happen from minus pi to 0? Suppose this extension is again in this is my extension, say, right? In this way I extend it, right? So now here, suppose the possible extension is here in the third quadrant. This is the possible extension, say, right? This is the possible extension, say, right? So now what will happen to this function? Now this is symmetric about the opposite quadrant, right? Symmetric about the opposite quadrant. So it will lead to odd extension, right? It will lead to odd extension, right? It will lead to odd extension. Likewise, if we have the extension is like this, suppose we have the even extension. This is my original function. Defined in 0 to pi. This is my 0 and this is my pi. Suppose I extend it here in the second quadrant, say, right? This is my extension here. So now it is my minus pi to 0. Now what we observe, it is symmetric about, right? It is symmetric about y-axis. So it is my even extension, right? Even extension. So now this will lead to here half range cosine expansion, right? This will lead to half range cosine expansion, and this will lead to half range, right? Half range sine expansion, right? So the odd extension will lead you to half range sine expansion, right? Odd extension lead you to half range sine expansion, and the even extension lead you to half range cosine expansion. So now what is my given function? My given function is fx is equal to x in half of the interval. Now what is my this extended function? This extended function is my fx is equal to, so what will happen to when minus pi less than x less than 0, and it is my given 0 less than x less than pi is given. It is my x here and it is my minus x. The extension is this, or in general it is my modulus of x from minus pi less than x less than pi. So this is the extended function, and here what is the extended function? The fx is that same x, right? Fx is that same x minus pi less than x less than pi, right? In that way we can have the odd and even extension of the function, odd and even extension of the function, and it will generate the half range sine expansion as well as the half range cosine expansion. So let me to write the formula for the half range expansion. Prior to that, let me to introduce myself. Myself Professor S.K. Paikray, Susanta Kumar Paikray, currently working as a Professor of Mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. Okay, so to get such type of lectures, my appeal to all of you, please like and subscribe to this channel and share it with your friends, so that whatever the new lecture will be uploaded, it will come to your screen for your benefits. Okay, so let me to write the half range sine and cosine expansion. Now coming to the formula for half range sine and cosine expansion. As I have told you, let fx be defined in 0L, half of the interval. Bp is equal to 12 periodic, right? Then what is the half range sine expansion? The sine expansion means if we have the odd extension, then your fx is summation n equal to 1 to infinity bn sine n pi by lx, and your half range cosine expansion is your fx will be a0 plus summation n is equal to 1 to infinity an cos n pi by lx. So what is your bn? Your bn is equal to 2 by l 0 to l fx sine n pi by lx dx. Likewise, what is your a0 and an here? Your a0 is 1 by l 0 to l fx dx, and your an is equal to 2 by l 0 to l fx cos n pi by l x dx, right? So here you note that same functions, okay, same functions can have both even and odd extensions. Consequently they have both half range sine, cosine and sine expansion, respectively, right? However, in case of Fourier series, okay, the function may be either even or odd, or it may be neither even nor odd category, right? Because the function here is given in half of the interval, right? We can have the both extension is possible, right? So this is what it is different from the previous Fourier series case, and here, right, it is defined in 0 to L. Whatever the upper limit is given, it is my L. It is important to identify L, but the function is 2L periodic. So let me to solve some examples so that your idea will clear. Coming to example 1, you are asked to find the half range cosine expansion of the function fx is equal to x into L minus x. L is L arbitrary, okay. So coming to the solution, what is your L here? L is L, right? L is your L itself, right? But what is your period here? P is equal to 12 periodic, right? The function is defined in half of the interval in 0 to L, right? Fx is defined in 0 to L, right? We have to find its half range cosine expansion. The half range cosine expansion of fx defined in 0L is given by your fx is equal to a0 plus summation n is equal to 1 to infinity an cos n pi by lx. L is your L. Now to find a0, your a0 is equal to 1 by l 0 to l fx dx is 1 by L 0 to L here x into L minus x dx. So if you integrate it, it will be 1 by L 0 to L Lx minus x square dx is equal to 1 by L. The integration of x here is x square by 2 minus it is here x cube by 3 0 to L. So here 0 will not work here. So this will be 1 by L here L it is here L cube, it is here L cube by 2 minus here L cube by 3. Okay. So that is equal to here L square by 6. So we got that is my A0 is my L square by 6. Now likewise we find what is your AN, right? To find AN, here AN is equal to 2 by L 0 to L fx cos n pi by Lx dx. So this is equal to 2 by L 0 to L here Lx minus x square is my fx and it is cos n pi by Lx dx. So we apply integration by parts rule here, so that will be my 2 by L first function silent Lx minus x square integration of cos n pi by L is sin n pi by Lx divided by n pi by L, right? Divided by here n pi by L being a constant, right? Minus, put a negative sign, the derivative of this is L minus 2x and integration of sine is minus cos n pi by Lx. This divided by, already we have n pi by L, again we have n square pi square by L square. Then put a positive sign, right? Put a positive sign. The derivative of this is minus 2 and the integration of this is minus sine n pi by Lx and again n pi by L will be divided. So it will be here n cube pi cube by L cube. Put a negative sign. The derivative of this is here 0. Okay, so we'll stop here. It is my 0 to L. So if you substitute L and 0, it becomes sine n pi sine 0. So this will here 0 and this will here 0. Only this term will exist. So you simplify it to get. Now if you simplify, it is here 2 by L. Then it is here minus plus. It is putting L here, L minus 2L minus L cos n pi by L. And here again for the second limit you have minus, putting 0 here minus L. So it becomes here minus 2L and this will be multiplied here. It is L square by n square pi square. Okay. So we have one correction here, cos 0 is here 1, cos 0 is here 1. So it will be here minus L cos n pi minus L into cos 0 is here 1. Okay. L and x is L cancel here. So this is simplified to give you L taking common, L cancel, it is here minus 2L square by n square pi square cos n pi is minus 1 to the power n and it is plus 1, right, 1. So this is here an. Now you substitute this in here, let it be your equation number star. Now star follows here fx is equal to a0 is here L square by 6 minus here an. Okay, it is minus 2 L square by pi square summation n is equal to 1 to infinity and it is here minus 1 to the power n plus 1 by n square. I bring n square inside because n varies here, n square, and it is here cos n pi by Lx. Okay, and if you like you may simplify it or you may leave it here, right, you may leave it here. So let us solve two more questions. Now coming to example 2, fx is equal to x square 0 less than x less than pi. So what is your L? L is your pi here, right? This upper limit L is your pi. But period is 2L, it's 2 pi periodic, right? 2 pi is my period, right? So what is the half range cosine expansion? As half range sine expansion, here fx is simply summation n is equal to 1 to infinity Vn sine and pi by Lx. So L is my pi here and pi by Lx. So this is summation n is equal to 1 to infinity Vn sine, L and pi cancel, it is nx, right? Let it be my equation star. Now you find here, find Vn. Vn is equal to 2 by L integral 0 to L fx sine and pi by Lx dx. So this is my 2 by pi 0 to pi, the value of fx is x square, it is sine nx dx. So integrate by parts here, it is 2 by pi, it is x square silent, sine nx, the integration is minus cos nx by n, put a negative sign, the derivative of x square is 2x, integration of this is minus sine nx by n square, put a positive sign, the derivative of 2, the integration of this is cos nx by n cube. Okay, limit is 0 to pi. So within 0 to pi, here sine nx is here 0. So now if you simplify it, it will be a 2 by pi, substituting pi here, it is minus of pi square cos n pi by n. Then here 0 will not work for this first term. Coming to the second term, putting pi here, it is 2 by n cube cos n pi, and putting 0, it is 1, cos 0 is 1. Okay, so it will be here 2 by pi cos n pi is minus 1 to the power n. So this minus sign we can have minus 1 to the power n plus 1, it is pi square by n, and it is minus 1 to the power n, 2 by n cube, and it is here minus 1 to the power n and minus 1. Okay, so this is my Bn, and accordingly you substitute in star. Now star follows, now equation star follows, fx is equal to summation n is equal to 1 to infinity Bn sine nx, where Bn is my this, Bn is equal to this. Okay, so this will be your answer, right? Coming to one more example. So coming to your example 3, so here this pi is your L. Okay, so your L is equal to pi here, but what is the period? Period is equal to 2L is equal to 2 pi is the period, right? So we need to find both half range sine and cosine expansion, right? Now coming to half range sine expansion, right? Half range sine expansion, here fx is summation n is equal to 1 to infinity Bn sine n pi by Lx. So this is here summation n equal to 1 to infinity Bn sine, L is here pi, so it is simply nx, right? Let it be my equation star. Now to find Vn, to find Bn, Bn is equal to here 2 by L, 2 by pi 0 to pi, directly I am writing fx sine nx dx, because pi is here L. Now the value of fx from 0 to L, from 0 to L only, right? From 0 to L only. So we have to split it, 0 to pi by 2, then pi by 2 to pi. So this is here 2 by pi integration 0 to pi by 2. The function is x, right? X sine nx dx plus accordingly pi by 2 to here pi. What is the function here? Pi minus x sine nx dx. So we have to simplify it, right? We have to simplify it. So this will be equal to 2 by pi, you apply by parts here, it is here x, integration of this is minus cos nx by n, put a negative sign, the derivative is 1, integration of this is minus sine nx by n square, right? n square. So here the limit is from 0 to pi by 2. Then put a positive sign here. You apply by parts here. It is here pi minus x, integration of this is minus cos nx by n. Put a negative sign. The derivative of this is minus 1, integration of this is minus sine nx by n square. Then subsequently next the derivative is 0. So the limit is here 0 to pi by 2 to here pi. Okay, now you simplify. If you simplify it, it will give you 4 by pi n square sine n pi by 2. Okay, so this is equal to your 4 by pi n square minus 1 to the power n minus 1 by 2, n equal to odd and 0, n equal to even, or you may simplify it. So now your equation star follows, right? Now your equation star follows. Fx is equal to your 4 by pi summation n equal to 1 to infinity 1 by n square sine n pi by 2, right? And it is sine nx, right? So this is the desired half range sine expansion. Accordingly, your half range cosine expansion. To find half range cosine expansion, what is the half range cosine expansion? Here fx is equal to a0 plus summation n equal to 1 to infinity n cos n pi by l, means nx here, nx, right? It will be equation star because here l is equal to pi here. Okay, accordingly what is here a0? A0 is 1 by l 0 to l fx dx, and here an is 1 by 2 by l 0 to l fx cos n pi by lx dx, right? So now to find a0, so what is your a0? A0 is equal to 1 by pi 0 to, we split it, 0 to pi by 2, it is x dx plus your integral pi by 2 to pi, here pi minus x dx. If you simplify it, it will give you 1 by pi, it is x square by 2 from 0 to pi by 2 plus pi x minus x square by 2 from your pi by 2 to pi. If you simplify it, it will give you here pi by 4, right? So a0 is here pi by 4. Now to find an is equal to, similarly here 2 by l integral 0 to l, means I am directly writing 2 by pi and I split it 0 to pi by 2, the functional value is x cos nx dx plus here pi by 2 to pi, functional value is pi minus x cos nx dx, right? You apply by parts now. In both cases you apply the by parts. It is 2 by pi. If you apply by parts here, x integration of cos nx is minus sine nx by n, put a negative sign, the derivative of x is 1, integration of this is here cos nx by n square. Okay, it is here 0 to pi by 2, and plus you apply by parts here again, it is pi minus x, past function silent, integration of second is here 1 second, this is here plus sine and it is minus here, so it is here sine nx by n, put a negative sign, the derivative of this is minus 1 here, and the integration is minus cos nx by n square. The limit is pi by 2 to pi. Now you simplify it. If you go on simplifying, it will give you minus 2 by pi n square. Okay, if you proceed, and you will be getting this minus 2 by pi n square, it is 1 plus minus 1 to the power n minus 2 cos n pi by 2. If you further simplify it, it will give you minus 8 by pi n square when n is equal to 2, 6, 10 and so on. Okay, so accordingly what will be your equation double star? Let it be my equation double star. Okay, let it be my equation double star. So now double star follows. Now equation double star follows. Here fx will be pi by 4 minus 8 by pi, summation of n is here 2, 6, 10 so on up to infinity. It is 1 by n square cos nx. If you split it, it will give you pi by 4 minus 8 by pi. It is 1 by 2 square cos 2x minus 1 by 6 square cos 6x, minus we have taken common, so it will plus. Then next will be here, continue in this way. For n is equal to 10, it is 1 by 10 square. 1 by 10 square cos 10x plus da 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 da. So which is the desired answer? Okay, which is the desired answer, right? So now with this we have completed the Fourier series. You just go through all these lectures. First one is the in this playlist you will find the periodic function, then Fourier series of 2 pi periodic function, then you will find the Fourier series of arbitrary periodic functions. Okay, all the lectures are supported by several examples, and here it is your half range sine and cosine expansion. Okay, so we should conclude the lecture here. So before I conclude, my request, once again I request you, please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures for your benefits. Thank you all.